All right, let's finish section 1.3 with a very important example about constructing a grouped frequency distribution table. Okay, so the frequency distribution table that we just created had pretty much just categories where it's just whole number categories right there, or single categories right there. For large data sets, it becomes necessary to group the data into classes, okay? And so a grouped frequency distribution table, and I'm going to abbreviate that a lot as GFDT, is a frequency distribution where data is grouped into class intervals. So rather than just having a category for the zeros, the ones, the twos, the threes, the fours, we actually might have a range of an interval that gives us a range where each class contains different values. So let's break this down, and there's a lot to absorb right here. So class intervals are equal in size, meaning the differences between consecutive lower limits of each interval are the same. For example, if a class interval goes from 30 to 39, okay, this is what I mean by like an interval or some range of values. And then the next interval would go from 40 to 49, okay, for example. Then the class width, okay, definition right here, the class width, or sometimes called the class range, is just the difference between consecutive lower class limits. Okay, so the lower class limit on this one is the 40. So the lower value is the 40, and then the other lower value is the 30. So 40 minus 30 is 10. That's the class width. It also works if you do the difference in the upper class widths. So like the 49 minus the 39 is also 10. Okay, all class intervals combined must contain all data in the set. So to find the class width, to make sure that it does what we need it to do, subtract the smallest data value in the set from the largest data value and divide the results by the number of desired classes. Okay, and you'll pretty much just be told what number of classes we want to use, just to make sure that all of our tables come out with the same answers. Okay, but again, there's a lot of freedom in statistics, especially if you're doing your own research of how you want to do it. Okay, but you'll be told the number of classes for the examples. So the class width is going to be the largest data value minus the smallest data value divided by the number of classes that you want to use. Okay, we always want to round up, and we want to use the same number of decimal places as was in the data. Okay, and this is going to ensure that all of the data will be contained in a class, in at least one of the classes. We don't want any of the data to fall outside of our classes as we're constructing these. Okay, choose a convenient starting point. And again, it's up to the statistician of how they want to do this. But a good idea is the smallest data value or something slightly below that. Okay, and this is another one where I'll typically give you where I want you to start it from, just so that your table and my table and your partner's table, everybody's table ends up being the same. Because yeah, there's a lot of flexibility once you become a statistician and you want to organize the data yourself. Once we do an example, all of these terminology will make a lot more sense as you see it. Okay, the class midpoint of each class is found by finding the average of the lower and upper limits of a class. So we're just going to add up the upper and lower limits and divide by 2. Okay, I'll show you. Pretty easy to get that part. Class boundaries is a little bit tricky. So class boundaries are the numbers used to separate the classes, but without gaps in between the class limits. Okay, and that's going to be really useful for when we're constructing histograms, which we're going to do in chapter 2. And so what I mean by without gaps between the class limits, if I go back to this example of like 30 up until 39 and then 40 up until 49, notice that there's a gap between 39 and 40. Technically, if you're thinking about just like a number line, there's a gap there. Okay, so we want to make sure that we fill in the gap as much as we can. Okay, when you're displaying the data, especially in a histogram. So to find class boundaries, this is the technique, and it'll make a lot more sense once we start doing it by hand. But you want to add or subtract a decimal value of a 5 to one more decimal point than the data contains on each endpoint of each class. Okay, so let me explain what I mean by that. If a class interval goes from 20 to 30, for example, what we would do is one extra decimal point with a 5, if we're using whole numbers, would go to 0.5. And so what we would do is we would subtract 0.5 from the lower limit 20, and it would bring it down to 19.5. And then what we would do is we would add that 0.5 to the upper limit of 30. And that's a typo right there. This should be 30. I'll fix that when I make a new copy. And that'll be 30.5. Okay, so what that does is it makes it so that the two classes don't have any gaps in between them if we start trying to graph these on a histogram. Okay, if we have more decimal values, so for example, if we have a class interval that goes 1.8 to 2.6, when we add or subtract that 5 to one more decimal point in the value, since this data right here has a 1 decimal place, we have to go to 0.05. So that's an extra decimal place. Okay, so we subtract the 0.05 from the lower limit, which would give us 1.8 minus 0.05 to get 1.75. And we add the 0.05 to the upper limit to get 2.6 plus the 0.05 to 2.65. So as we work that out, it should make a little bit more sense, but that is a little bit of a tricky thing that takes some getting used to. And so, yeah, this is going to be a little bit of a long video, but this is an extremely important example here. I'll definitely have a test question where we construct a grouped frequency distribution table. So here we go. Let's do it. Example 3. We're going to do it for the following data. And like I said, I'll tell you how many classes I want you to use. And then I'll also tell you the best way to use the starting point for the lower limit of the first class. And then here's the table setup where we're going to have our class intervals, our class boundaries, our class midpoints, and then finally we'll do the frequency, meaning how many pieces of data fall within each of those classes. Okay, so first things first, we need to find out the class width. Okay, so the class width okay, and like we said up here, it's found by finding the largest data value minus the smallest data value divided by the number of classes. Okay, so we want to go largest minus smallest, divided by the number of classes. So this is just raw data kind of scattered all over the place. So what's the largest value? So kind of hunt through here. We technically don't need to put all of it in order. That would be a little bit of extra work, but it looks like 4.1 is the largest data value. So I'll write that as 4.1 minus, okay, and then we got to hunt through here and find the smallest. 0.9, 0.8. Is that the smallest? Take some time, be careful with these. But yeah, it looks like the 0.8 is the smallest. And then the number of classes, it told us to use 5 classes. So that's going to be divided by 5. Okay, so I'll type this into the calculator and be a little bit careful because it's a common mistake to enter this into the calculator incorrectly. So I want to actually just display how I would write that. 4.1 minus 0.8. The way I want to write that is 4.1 minus 0.8. And then before I do divide by 5, I want to press enter because if I just type to divide by 5 in the first place, the calculator thinks that I would only be dividing the 0.8 by a 5. So now what I want to do is press divide by 5. And then I get this 0.66 number. Okay, so we get 0.66. But remember, and we got to be careful, for that class width, we always round up, and we want to use the same number of decimal places as the data. Okay, so going back here, 0.66, we want to round up, and notice that all of the data has 1 decimal place, so we want to round up. Even if it was like 0.61, I would still round up to 0.7. We always round up to make sure that all of the data is going to fit inside some class. Okay, so that's to 1 extra, or to the same decimal place as our data. Okay, now it said use the smallest data value as the lower limit for the first class. So we already circled that smallest data value of the 0.8. So I'm going to go 0.8, the lower limit of the first class. And now this class width tells us the distance that we would go to the next lower limit of the next class. So I want to go plus 0.7. Okay, so we want to add the class width. Okay, so I'm going to go the 0.8 plus 0.7, and we get 1.5. And we go again. Okay, all of these have to be that same class width each time. So 1.5, I'm going to go plus 0.7 again, and I'm going to get 2.2. So these are just the lower limits of each class. And we're going to go plus 0.7 again to get 2.9. And again to get 3.6. Okay, and now I use like a little dash here to indicate that these are going to go from these lower limits up until some upper limits. Okay, and a good way to think about it is the first thing that we can think about is you got to go this 0.8 right up until we get to the 1.5. So going to the same number of decimal places as the data, we would have to stop at 1.4. Okay, right before I get to 1.5. Okay, and then you can still use that same strategy. 1.5 would have to go right before we get to the next one. So I know it's going to go to 2.1. But you can also do the same strategy of adding that class width, the 0.7, each time to the upper class limits. And that's going to still be the same value each time there. So that's another way that you can think about it as well. So 1.4 plus the 0.7, that means that this one ends at 2.1, which makes sense. That's right before I get to 2.2. And then if I go 2.1 plus the 0.7 again, that class width again, we get 2.8, which should make sense because it's right before we get to 2.9. And then plus 0.7 again, 3.5. So that's right before we get to the 3.6. But then we need to go one more time. And it ends at 4.2. All right, so those are the classes. Okay. Now for the class boundaries. And in my opinion, these are the trickiest parts. So for the class boundaries, like I said, and I'm going to scroll back up here to talk about it. For the class boundaries, you want to add or subtract a 0.5 or a 0.05, which is one more decimal place than the value. So we're going to subtract from the lower limit. Okay, we subtract from the lower limit, and we add that value to the upper limit. And it's going to end up really making sense. Once we do the first one, all of the rest of them kind of just fall into place. So for the class boundaries, what we want to do is we want to take the lower limit of the 0.8, and we want to subtract, and maybe I'll write with different notation. I want to go 0.8. I'll write it like this, minus. Okay, so we've got to go one more decimal place with the 5 than the data. So this is one decimal place out to the 8. So I need to go 2 decimal places with the 5. So we're going to go 0.8 minus 0.05, and we get 0.75. So that's going to be the lower class boundary. And it's going to go up until we get to, and now we go 1.4, and we add this 0.05 number to the upper class limit. So 1.4 plus 0.05 is 1.45. 1.45. Okay, and then the really nice thing about that, even though that's a little bit tricky and it takes some getting used to, that 1.45 should be exactly where we start with the next one. Because if I take the 1.5 from the next one, if I go and kind of do some scratch work, if I do the 1.5 and I subtract the 0.05, just like that same process. It would be the same procedure again and again and again. But if we go 1.5 minus the 0.05, it gives us the 1.45, which is where we left off. And that's the whole point of these class boundaries, is we want them to pick up exactly where the previous one left off, so there's no gaps. Okay, so let's use that strategy. This one leaves us off at 1.45, so this one's going to start at 1.45. And then for this one, for the 2.1, I would go 2.1 plus 0.05, and I got 2.15, which means this one picks up at 2.15. And now for the upper one, I'm going to go 2.8 plus 0.05, and it's going to go 2.85. Notice how it just gives one further decimal place with a 5 in that direction. And then this is going to pick up at the 2.85, and then it's going to finish at 3.5 plus 0.05, 3.55, which means this one, and if you want to work it out, 3.6 minus 0.05 is going to give us 3.55, and it's going to finish at 4.25. So class boundaries, in my opinion, is the most tricky part of that, but they kind of they really do fill themselves out once you get started. Okay, I know this is getting a little bit long, but very, very important. I'll have a test question on this for sure. Okay, class midpoints. So the class midpoints is really just the average of the upper and lower values from any one of your classes. Okay, so this is just going to be 0.8 plus 1.4, and we divide that by 2. Okay, so for the sake of speed, I'll go through and just do this pretty quickly. So just add those up and divide by 2, we get 1.1. For the next one, we would have 1.5 plus 2.1 divided by 2, and that comes out to 1.8. For the midpoints, we're using the classes, not the boundaries. 2.2 plus 2.8 over 2. And this ends up following a nice pattern. These should actually be going up by the same value each time. 2.9 plus 3.5 divided by 2, and we get 3.2. And then 3.6 plus 4.2 divided by 2, and we get 3.9. Okay, so those are the midpoints, and we're going to need midpoints when we're doing different types of graphs a little bit later as well. So all of that work, now we're ready to actually do the frequency of all of our data values that fall within each of these class intervals. Okay, so I'm not going to worry about the midpoints or the boundaries right now. I'm just going to go to these different class intervals. So we want to just go through and tally them all up. And here is actually a place where it actually can be a little bit of a pain, because we got to make sure that we count these just right. So I'm going to erase those, and I want to make sure that I'm very careful here. I want to make sure that I don't leave anything out, and I don't want to double count stuff because it's a little bit tricky. So as I go through here, I believe there's 33 different data values. So I'm going to make a note to myself that I should have a total of 33 when I'm done, just to make sure that I don't leave any out or don't double count any. So what I want to do first is I want to go through and I want to find all of the different values that are somewhere within 0.8 to 1.4. Okay, so here we go. Everything that's between 0.8 and 1.4. So let's see. 1, 2, 3, 4, 5, 6, 7. Okay, very careful. I want to be very careful. So it looks like there's 7 that fall within that class. Okay, next one. I want to do all the values that are in between 1.5 and 2.1. Okay, so here we go. Between 1.5 and 2.1. 1, 2, 3, 4, 5. Okay, very careful. 5 land in that class. Now I'm going to go everything that's in between 2.2 and 2.8. Okay, so here we go. 2.2 to 2.8. 1, 2, 3, 4. And that's it. I got 4. Okay, now I need to go everything from 2.9 to 3.5. Okay, 2.9 to 3.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, sounds good. Being very careful. All right, and then the last one, 3.6 up until 4.2. 1, 2, 3, 4, 5. Okay, looks like every single one of them is crossed out. But here's where I want to check, and I want to make sure, does this all add up to the 33? And that's a quick way to just check that you're probably right, that you got them all. So 7 plus 5 plus 4 plus 12 plus 5. Whew. If that does not come out to the exact number of data points, then you got to try again and make sure that you get all of those, because assuming that you did your class setup correctly, all of the data should be accounted for, and it should add up to the exact correct amount. If it doesn't add up to the exact correct amount, then maybe as you're going through here, you probably just missed one, or maybe you double counted one or something like that, okay? So it's a good idea to keep track. And once I finish these, I absolutely want to check to make sure that that total adds up to the exact number of data points. Okay, so kind of a long process there, but there'll definitely be a test question where I have you construct a grouped frequency distribution table like this. Okay, so that finishes off section 1.3.